Today we are going to learn about the universe, the galaxies, the black holes, the Earth, everything related to the universe. Akshay, could you please introduce yourself and what do you do for business?
Yes, firstly, thank you very much for this special invitation for the talk. And yes, we will discuss a little bit about the universe. And firstly, if I talk about myself, I am Akshay Kumar and I hail from Rajouri, Jammu and Kashmir, which lies in the northern part of India. And presently, I am doing astrophysics and cosmology at the Department of Physics and Astronomy, Galileo Galilei, at the University of Padova. And yes, furthermore, I am also planning to pursue my further research in the same department. Yes, okay.
How did you get inspired to join this study or this branch?
Okay, you mean how I get interested in
Yes,
astrophysics
yes,
and
yes.
okay. Well, I grew up in a small rural family town in Rajouri, Jammu and Kashmir. Uh, I, in my that village, the sky was stunningly beautiful and dark. And after looking at the sky, it seems that those stars call my name. They caused me to ask question like how many stars are there, why are they like, and what is beyond what I can see. I still remember that bunch of stars in an arc that look weird at that time when I was in childhood, but later on when I studied, I was connected from my childhood to the Milky Way galaxy. And yes, I can say that to go out and see the universe, that's what got me interested in astronomy. And then after that, for me, learning physics was the absolute enjoyment of understanding the things that you visually perceive and experience through the principle that govern them. And then similarly, mathematics to me was a beautifully imagined game with its own set of rules. And there was never dull a moment when it comes to problem solving. And I continued this interest. And therefore, here I am in a prestigious institute and doing astrophysics, which is quite a satisfying job for me. I want to be an astrophysicist and to understand the mystery of the universe. For example, why we are here and are we alone in this universe, and galaxies, stars, black hole, and the origin of universe, and so on. So I'm lucky that I'm in the department where once Galileo and Galilei were professor in this department. So yes, I'm very lucky, and also I'm doing quite good astrophysics here in the department. Okay.
Congratulations, Akshay, and all of
Yeah.
that. So
Thank you very much. And
my first question: what are galaxies?
yes. So a galaxy is basically a system of stars, stellar remnant, interstellar gas, dust, and these all are held together by gravity. And galaxies are the building block of the universe. And now astronomers have estimated that there are over 125 billion galaxies in the universe. Yes.
Okay, and okay, my next question is: what are black holes?
Okay. Fine. A black hole is a place in space where gravity pulls so much that even light cannot get out. The gravity is so strong in black hole because the matter has been squeezed into a tiny small space. This can happen when a star is dying because no light can get out, and people can't see black hole because they are invisible. And yes, we astronomers and astrophysicists we use special tools that can help find black holes. And we astronomer have particularly on the basis of observation and because of the gravity effect, we have defined the types of black hole. And the first one is a stellar black hole, and the second one is a intermediate mass black hole, and the third one is supermassive black hole. Yes. So
What?
there is different range. There is different range for these different type of black holes. For example, for the stellar black hole, its mass is 3 to 10 solar mass, and for the intermediate, it is from 10 raised to power 2 to 10 raised to power 5 solar mass. And for the supermassive black hole, it is more than million to billion solar mass. And the special thing which I want to mention here is that even in our Milky Way galaxy, we have supermassive black hole at the center of our Milky Way galaxy. And mm, recently, the mass of that black hole is 4 million solar mass. So it means that you have to multiply like 4 million to the mass of the sun. So that is about the supermassive black hole. Okay, this is all about the black hole and their type.
Yeah, that's really super big, super huge.
Yes, 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 it is. It is.
So, how does the black hole evolve?
Okay. Well, the answer to this question is very time consuming because it's not possible to explain every research in just a small small like interview. So I will do my best and try my best to give you the answer in a very gist.
Okay.
So firstly I will talk about the stellar black hole, which are very small but deadly. When a star burn through the last of its fuel, the object may collapse, okay, or fall into itself. For smaller stars, the new core will become a neutron star or a white dwarf star, okay. But for a larger star collapse, it continue to compress and create a stellar black hole. So the another thing, supermassive black hole, the the birth of this giant supermassive black hole is still in research. That, but still, astronomers say that such black hole are thought to lie at the center of pretty much every galaxy, including even our own Milky Way galaxy. These enormous black hole are million or even billions times as massive as the sun, but are about the same size in diameter. And these supermassive black hole may be the result of hundred or thousand of tiny black hole that merge together. And large gas cloud could also be responsible collapsing together and rapidly accreting mass across the center of black hole. And the third could form when star in a cluster collide in chain reaction. And several of these intermediate mass black hole forming in the same region could even eventually fall together in the center of a galaxy and create a supermassive black hole. Yes. So,
Great.
yes.
Yeah. So, what happens to light in the black hole?
Yes, it's a really good question and quite interesting. Even I wish I know that what happened to the light when it go to the black hole. But what for now I will say that it is true that light particle can't escape a black hole, but that doesn't mean that they are destroyed. Once a particle of light, which is photon, passes the event horizon of black hole, it can no longer escape. Okay, but there is nothing to suggest that it is destroyed. So like matter, the photon is rapidly sucked toward the singularity at the center of black hole, where a huge mass is packed into an infinite small space. What happened to photon at these extreme condition, however, is one of the astrophysics big unanswered questions. So I really want to say to thanks to you because you raised this question still that you are not doing astrophysics. So really, thank you very much. Thank you very much for this question. Yes.
Okay, so my next question, how long does a black hole live?
Yes, it is also very again interesting question. Black hole have a finite lifetime due to the emission of Hawking radiation. So this Hawking radiation is the concept given by the Stephen Hawking, which is which was also a very great astrophysicist and one of my favorite astrophysicists. And he mentioned that for most of the known astrophysics black hole, the time it would take to completely evaporate and disappear is far longer than the current age of the universe. For example, if black hole evaporate under Hawking radiation, a small solar mass black hole will evaporate about 10 raised to power 64 years, which is very vastly longer than the age of the universe. And also for the supermassive black hole with a mass of 10 raised to power 11 billion solar mass will evaporate in 2 multiplied 10 raised to power 100 years. So now you can imagine that how long will it take to evaporate the black hole. So it's very, it's very like long time they will take to evaporate. And yes, some monster black hole in the universe are predicted to continue to grow up to about 10 raised to power 14 solar mass during the collapse of supercluster of galaxies. Even these would evaporate with a time scale of 10 raised to power 106 year. I know that these figures are very big, but still what we are saying is just because we are getting the result from the observation. Yes.
Great. Can the sun turn into a black hole?
No. So yes,
So we are safe.
basically yes, we are safe. Yes. So
Okay.
basically, it's really an interesting question for all those who did not know about the black hole. But yes, no, the sun will never turn into a black hole because the sun is not a big enough star to make a black hole. And the another important thing I want to mention here that few of students who are not aware about this point, I'm talking about those who are not doing science. So the sun is also a star, but it is not enough big that it will convert into black hole and we all will be sucked. No, the sun will never turn into a black hole. Yes, it's very interesting question.
Okay,
Okay.
can the Earth be swallowed by a black hole?
Yeah, wow. I like this question. Usually people ask me this question. Yes, okay. Black hole do not go around in space and eating stars, moons, and planets. Earth will not fall into black hole because no black hole is close enough to the solar system for Earth to do that. Even if a black hole has the same mass as the sun were to take the place of the sun, Earth will would not fall in. The black hole would have the same gravity as the sun. Earth and the other planet would orbit the black hole as they orbit the sun now. Got it? Uh, yes.
Okay.
Yes.
Okay. So my next question is, do black holes affect the Earth?
Yes. So thankfully, though we don't need to worry for this because there are no black holes close enough to Earth to affect us. The closest black hole, as per observation, to Earth that we know of is V616 Monocritus black hole, which is about 3,500 light year away. And that is very far away from us. So we don't need to worry about the black hole.
Okay.
But still, people usually ask this question, and I really really feel blessed that I'm doing astrophysics, so I am able to answer these questions.
Yeah,
Thank
that's
you.
a great pleasure talking to you. So my next question is, how do
Yes.
science measure a black hole?
So by this question, you mean to say that how we measure the mass of black hole, right?
Yeah.
So well, to measure the mass of black hole, we have different method, and here I will just name those method. The first method we used is stellar kinematic in the galaxy, and the second method we use water measure kinematics, and the third method is ionization, ionized by ionized gas and stellar kinematics in nearby galaxy, and the fourth is reverberation mapping, which we used to measure the mass of black hole in active galactic nuclei. So basically here I will explain only first or one or two method, because it is very so firstly, by the stellar kinematic in the galaxy, what we do, we measure the motion of those stars that revolve around Kepler law, and we use the basic Newtonian principle, and we use Einstein theory of relativity, and we measure the mass of black hole.
Okay.
Got it? And in the second technique, we there is a measure kinematic, water measure kinematics. So this technique is used, it is similar to like we use the laser technique. So laser here, L, which is light, it is just replaced by measure. Okay, so like microwave amplitude stimulate emission radiation. So by these radiation, we measure the kinematics of the gas that revolve around the black hole, and from that we measure the mass of black hole. And the third, we see the kinematics. Kinematics mean to the motions of the nearby galaxy, how black hole affect to the nearby galaxy, and by using some scientific formulas and from scientific observation, we measure the mass of black hole. And the fourth, which is reverberation mapping in active galactic nuclei. So my point is to measure the mass of black hole in active galactic nuclei. Here, active galactic nuclei is a galaxy in which the center part nucleus, which is black hole, is very active. Is very active. I mean to say, like suppose if we have black hole, and we have in the center of that black hole, we have sorry, in the center of that active galactic nuclei galaxy, we have black hole, and which is very active. To measure that black hole, we use the reverberation mapping. So reverberation mapping is just similar to echo of sound that we studied in very high school. Echo of sound, to measure the echo of sound, we use reverberation. So that concept is taken from that, because when jet goes in AGN, the sound is like B. So we measure from that sound the mass of black hole. Yes.
That's perfect. And what is your message to the people about astrophysics?
Oh, that is that I always want to give message to my all friends, and also to all the people from all over the world. So my first message is to the education system, that it is necessary to introduce astronomy as a subject from the school level, and I can assure every student will love this subject and get a chance to forge his or her career. And second, my message is for all the I mean to say everyone. My message is for everyone, those who wants to pursue a career in astronomy and astrophysics, those who complete their study with the specialization or a PhD and postdoc in astronomy and astrophysics, they are eligible to work as a research scientist, university faculty, and also in industries nowadays. with experience, having sophisticated astronomical instrumentation, and expertise gained in computer programming and data handling. So the scope of astrophysics is very, very interesting.
Perfect. What else would you like to add about this topic today, Akshay?
Yes. So the important in the end of my talk, I just want to give a message to all everyone who will see this video, and I just want to give my perception of life. So basically, I have a different perception of life, and I see the very existence of humanity with a purpose. You may term it in a way my philosophy, but I don't want to confine it in a single metaphor. Rather, I would love to engage in a discussion that would make my perception or philosophy more acceptable. So basically, many people have short term goals. We tend to start believing that we have achieved success upon achieving the goals. No, this is not the case. We must think that there won't be any full stop in success. There would be commas. You can't put a full stop to your success because success is not a destination. It is a beautiful journey done by you. And for me, my real motivation is to explore the mysterious universe and to do continuous work in the field of astrophysics. And anyway, I feel that we should do what make us feel great. If we can't do what we love, we should love what we do. If you fail to understand this, then you are like a dog that chases every car. You will eventually end up getting lost somewhere. So that's all. Thank you very much. It's been my pleasure, and I really appreciate this opportunity that through you I got this opportunity to give my message to all. Yes, thank you very much.
It has been great. It has been beautiful talking to you, Akshay. I really
Thank
appreciate it, and we hope nobody
yes,
loses
thank
their way. Thank you so much for that.
yes, yes, yes. Thank you very much. Thank